In the last segment, we looked in detail at a graph showing the movements of two articulators, velum and tongue back, or velum and lips, and how they combine to produce certain speech sounds in the context of specific words. Here we see a nearly complete gestural score, with some of the movement patterns represented just as in that last graph, but this time you see the movements for 4 different articulators: glottis, tongue body, here they mean the tongue dorsum, tongue tip, and lips. Some articulators have 2 parameters, one for the size of the movement and one for the type of movement. Notice that the velum is not represented in this score. It's okay, because the word that's represented here happens to have no nasal sounds in it. Because of this, the velum is assumed to be in one position, closed, throughout the articulation of this word. You see at the beginning the movement of the tongue back up to the soft palate, where it sits for a bit, a total of about 0.15 second, or 150 milliseconds. Then the tongue back moves again into its high back position for the vowel oo. It stays there for another 150 milliseconds or so, and then it returns to its rest position on the floor of the mouth. And just before the vowel ends, you also see the movement of the lips change. They come together, creating the closure necessary for the stop consonant p. The very fact that the lips are moving during the production of the vowel oo results in the phenomenon that we know as a formant transition. Once the lips are fully closed, the tongue body returns to its resting position on the floor of the mouth, and the remainder of the word involves the lips staying closed for about 150 milliseconds more, until the lips are released about 450 milliseconds after production of the word began. Most of the gestural accounts I see make use of a slightly easier to read kind of score. It looks something like this, with a line to represent movement of each tier of articulator. This one shows the velum, tongue tip, tongue body, lips, and glottis. Then the white box shows the time course for production of a particular sequence from left to right. Movement of each articulatory tier is represented as a bar. Where there's a bar, that tier is active, and where there's no bar, that articulator is in a default state. In addition to the time course of movement of each tier, many scores indicate something about the type of movement that's accomplished. So here you can see that the velum movement that's being represented is opening. It would be just as easy to represent closure of the velum on this score. The bar would just be in the other parts of the word. For a binary variable like open or closed, the two approaches will lead to similar results. So for this word, the first thing that happens is that the lips come together for a bilabial stop, and the velum is not open. So we know it isn't We then see that the lips open while the glottis is still open, so that air will still be free-flowing for a small amount of time after the lips have opened. The vocal folds will not be vibrating until the open phase of the glottis ends. So now we know that there will be a delay between the opening of the lips and the beginning of vocal fold vibration for a vowel. This tells us that there will be a relatively large voice onset time, which means that this will be a voiceless bilabial stop, or p. Next, the vocal folds will begin vibrating as soon as they're brought together, and they continue vibrating through to the end of the word. We also see that the tongue body is listed as pharyngeal wide, which is characteristic of low vowels, such as a. The next thing that happens is that the velum opens during the vowel. An open velum during a vowel means that the vowel is nasalized. As we know, it's typical in English that vowels become nasalized in syllables that are closed with a nasal consonant. So now we're expecting that there will be a nasal consonant at the end of this word. But which nasal consonant will it be? If the lips close again, then it'll be pam. If the tongue tip rises, the result will be pan, and if the tongue back is active, then it will be pang. And in this case, it's the tongue tip that rises, meaning that this score is a representation of the word pan. So this is how a gestural score can be read, rather like how a spectrogram can be read. In the end, you can tell quite a bit about what sounds are being represented just by thinking through the articulatory physiology of speech production. Gestural scores are good at showing how certain things can come about through movement patterns alone. These include processes such as assimilations, where one sound becomes similar to another adjacent sound, or deletions, in which a sound may disappear, or at least seem to disappear. We'll see a great example later of a deleted sound that's actually there, gesturally speaking. Or how sounds might resyllabify or rearrange themselves, especially in classic metatheses, where two sounds reverse position. However, gestural phonology is very clear that it doesn't capture everything of relevance in speech sound theory. In particular, it can't really deal well with things like the morphophonological interface. For example, we know that the plural of cat is cats, and that the plural of cad is cads. These two plural morphemes have very different phonetic realizations, and therefore they'd be represented differently in a gestural score. But there isn't anything in gestural phonology that attempts to explain why a person might become so good at predicting plural morphemes so quickly. Similarly, processes such as dissimilation are hard to account for under a gestural phonology account, although these processes certainly do occur at times. And lastly, gestural phonology has nothing much to say about perception. It's a motoric account from start to finish, and it doesn't make any pretense to deal with non-motoric issues. In the next segment, we'll look at how gestural phonology can represent sounds that might be present, but undetectable.